I'm saying there are some sample papers which are there on LMS, which you can refer. While attempting that, you will get an idea that what sort of questions are there, what could be the pattern, and what should be the question and answer look like. Okay, so that's what I was referring to, because Vasu asked that what could be the pattern, and so that you can refer to in the LMS itself.
Yeah, Simar, can you please explain the test of equal variances, because I could not recall exactly when to use this method.
Okay. So I'm just making a note of your queries and then I'll answer one by one. So test of equal variance is where you want apart from that.
One way ANOVA, please.
Okay, one way ANOVA.
The email that you have sent, it has the Excel sheet, went through that, but don't we have any slides for yesterday's training, or you'll be sending it together today?
I have a slide, but that slide only has one slide each for each test, wherein it has given some kind of explanation. But yes, I will give it to you. I haven't used the slides for the training, but yes, there isn't any extra material that which is not there. But yes, I can send that to you also after this training.
No problem. Thank you so much.
Okay, so test of equal variance, one way ANOVA. What else? Are we good with the remaining tests? Do we know when to use what? Are we able to understand the inferences out of the test that we did yesterday? Okay, so it looks like we are confident.
Yeah,
can I request?
It is clear, but yes, the practice is required.
Yes, same thing. Practice is required from my side.
Yeah, similar. Is there any way in which you can give some sample scenarios for which we don't know anything about it? We have got the data and we know what we are looking for. So from hypothesis creation to doing all these tests as per, picking the correct data and correct test type and then doing the data, etc. Can you provide us some exercises on that? So we'll have the data and we'll have what we are looking for, and then from hypothesis creation till the analysis, and we can do.
Okay, so there is an exercise file which I've shared last time, and this is the same raw data that I use for doing all these tests. So you can use that for doing that analysis. If you don't have, I can resend it to you, and you can use that data for doing these kind of hypothesis practice at home also. You can make those changes in the data, the numbers that you have, and then you can look for more variations as well. Okay, but yes, the data exercise file that I've sent is good enough, which you can use to do the analysis.
Yes.
So yesterday, if I just go back, can I request everybody to put yourself on mute? Anytime when it is required, probably then you can unmute. So test of equal variance is, we have already mentioned, Rahul. So we will be covering that as well. You mentioned that in the chat. Just saw that. So
okay.
These are the tests that we have covered yesterday. Including correlation, chi-square. We haven't covered one sample T and one sample T. We haven't covered one sample Z. We haven't covered Mann-Whitney, Moore's median, test of equal variance. BLR is something which we'll be covering today. 2P test is something which we'll be covering today as well. So let me write what all tests we'll be doing extra. So we'll be doing a regression test today. Okay. Apart from that, we'll be also doing gauge RNR hands-on. Okay, so we'll be doing these kind of tests today. So now the question that we have is the test of equal variance. Okay, test of equal variance is a hypothesis test which is to be done when your y is continuous and your x is discrete. So the example could be when you have a data for the number of units or probably the quantity of units produced Okay, so that could be your y continuous, okay, in kgs or maybe in grams, and your discrete data, your x could be a number of different sites, number of different factories, number of different managers, supervisors, etc. in the factory. So this could be a combination where your y is continuous and your x is discrete. Now in test of equal variance, what we do is we are trying to compare whether is there any significant difference between the variance of these three samples that I'm talking about, these 2 or 3 samples. Okay, so I'll just write it here. So test of equal variance establish if there is a significant variance between the axis or the subgroups that we have. Okay, so if there is if the p-value is lesser than 0.05, which means it's an alternate hypothesis, which would conclude that the variance of the samples are significant different from each other. So example could be, if I talk about, there's the same example that I've given. So the example could be for factory 1, the variance is 15 kgs. For factory 2, this is the variance that we're talking about, not the mean or median, is 22 kgs. Factory 2, okay, and factory 3 variance is, okay. So looking at these variants, we don't know whether these three values have any significant difference, because 15, 22 and 44 mathematically might be significant, might not be significant. It all depends upon the data. So for this, I will do a hypothesis test to conclude whether these three samples have significant variance or not. Okay, let's do a quick hands-on quickly on it, and then I will show it to you. So I have a data here. I'm just putting it on Minitab. So to do the test of equal variance, I go to test, okay. I go to ANOVA, I click on test for equal variance. In the response is always Y. So let's say I am comparing it with HT, that the Y continues that I have, and the factors that I have, which are my discrete, is the marital status. Okay, I click on OK. Now here in this graph, I can see that there are two p-values here. Okay, if this data is normally distributed, I would consider the multiple comparison p-value. If the data is not normally distributed, I would consider Levene's test p-value. Okay, so this p-value will tell me whether there is a significant difference between the variance of single versus married. Okay, so that's what the test of equal variance tells me. In this example, the p-value for both the scenarios, no matter whether it's normal or not normal, in both the cases it's an alternate, it's a null hypothesis wherein the p-value is greater than 0.05. So then I will conclude that there is no significant difference between the standard deviation of married and single. So you look at it, it's 268.298 and this is 268.059. So there is no significant difference between variance of married versus single. Is it clear to all of you?
Yeah, so that means we are not checking here normality. We are just comparing. We are just checking the variance between the groups.
Yeah, we are not checking the normality here. We have already checked the normality, Mahesh. This is to check whether if there is any sort of variance or not between two samples. So I'll just take an example to ensure that we understand the concept.
So Simranpreet, sorry to interrupt. Basically, we will first check the normalcy first, and then and when we do the test, so that based on the normality test that we have already done, we decide which result we should pick, and accordingly take our call.
Absolutely, that I always do. That for doing the test of equal variance, I would always check whether it's normal or not normal. I'm just sharing the reason why we are doing test of equal variance. What is the purpose of doing it? Okay, the purpose. Yes.
So Simar, just a question on this. For an example, if we don't do the test of equal variance, we determine that the data is not normal, and we go with the Mann-Whitney with multiple two or more subgroups. So in that scenario, it will give us the same interpretation, right?
Can you please repeat your question?
So if at all we don't go with a test of equal variance, but we have determined that the data is not normal, and we have say two subgroups. One was your marital status, and there's some other subgroup, and we do a Mann-Whitney in that case. Even that should give us the same interpretation, right?
Okay, so Mann-Whitney and test of equal. So you're asking what is the difference between Mann-Whitney and test of equal variance, correct?
So what I'm asking is, in Mann-Whitney, the figures that I'll get, if its data is not normal, in equal variance in the Levin's test, I'll get the same p-value. Is it right?
No.
Okay.
No, it is not. It is not. It is not same. Let me tell you that. So that's what I was trying to refer, because I can sense that there is some sort of confusion there in the group. Okay, let me just explain. Okay.
Sure.
There are two things. So this is very prima facie. This is very basic that I'm just talking about. In Six Sigma, we try improving the average performance. So for example, if today my breakage is 15%, okay? In a factory, if my breakage is 15% and I want to reduce that breakage to 5%, which means I'm improving the average performance. This is my average performance. So this is the average performance. That is called, now if I want to improve the variance, okay, maybe there is a variance of 10 and I want to reduce it to 4. That is a different thing. So let's take an example here. There are three different managers. Manager 1, okay. So I have their